Hi, in this video we're going to use Pythagoras theorem to solve problems involving touching circles. So let's see this question. We've got the diagram with three identical circles, all the same radius, inside a rectangle. Each circle touches the other two circles and the size of the rectangle as shown in the diagram. The radius of each circle is 14. Work out the area of the rectangle. Now, to work out the area of the rectangle, we need to find the length of the rectangle and we need to find the height of the rectangle. Now, to find this length for the rectangle, the horizontal length, that's a bit easier because we know the radius of each circle. The radius of the circle is the length from the centre of each circle to the circumference. We know that's 14. We also know that's 14 as well. Oh, sorry, something's gone wrong there. That's 14. We know that's 14 as well. That's 14. And therefore, we know the total length of this rectangle is just 4 times 14, which is 56. So we know that this is 56. That's great. But now we need to work out what is this height of the rectangle. And that's a bit harder. Now, the way we do this is to always join the centres of the circle. So we can join these two centres of the circles like that. And we can join these two centres as well, like that. And we know because this is 14 here, that's a radius, and this is 14 as well, this is a radius, we know that total length is 28. And then what we could do is we could form a right angle triangle, because notice this triangle in the middle here, that's an isosceles triangle. When we have an isosceles triangle, we can split it in half like this, and then we get a right angle triangle. And because we have a right angle triangle here, if I just shade that in yellow, and we know two of the lengths, we could find this third length here. And if we were to work out what this length is here, then we can add this length here. And notice this length is just a radius of the circle, which is 14. So that's 14, plus that unknown length, which we're about to work out. And this is also a radius of the circle, which is 14. And then we'd know the total height of this rectangle. Great. So let's concentrate on this yellow triangle we've got here. So this is the yellow one. And we know two of the lengths. We've got the 14 at the top. And we've got this 28, the hypotenuse, the longest length. And we want to find, let's call this x here. So we want to find this x. Now remember how Pythagoras theorem works. We do one of the shorter lengths of the right angle triangle squared, plus the other shorter length squared, so the 14 squared, doesn't matter which way the x and the 14 are around. And that is the hypotenuse, the longest side of the right angle triangle, squared, so 28 squared. Now we want to get x on its own, so we can subtract 14 squared from both sides. And then to get rid of the squared on the x, we could square root both sides. So we get the square root of 28 squared minus 14 squared. And if we do that, square root of 28 squared minus 14 squared, that is 24.2487. Now that's great because now we can work out the total height because we've got this length here of x, that length is equal to 24.2487. And then we also know this length here because, look, this is the radius of that circle, which is just 14, we know. And then we also know this length here because, again, that's just a radius of the circle, which is 14. And so the total height is just going to be the sum of those lengths. So we got 14 plus the 24.2487 plus this 14 at the bottom. And so if we add those, we get 52.2487. So we've got the height, and now we just need to find the area of the rectangle. The area of the rectangle is just the length times the height. So the length we said was 56, the horizontal length, and we times it by this total height, which we said was 52.2487. Times those together, and we get 2925.9272. How many decimal places? We want one decimal place, so the area is 2925 0.9 centimeters squared. And that is the final answer. Now, I'm just going to start this problem here, but we're not going to finish it. If you've got something like this, again, two circles, but different sizes, and we're told the radius of the larger circle is 9. So this is 9 here. And we're told the radius of the smaller circle is 6, like that. And we want to find the area of the rectangle. Now, because this is also 9, we know that this height of the rectangle is 18, so that's the easier bit. But finding the total length, the horizontal length of the rectangle is more difficult. And again, as before, we should always connect the centers of the circle. So if I connect these two centers like this, between these two centers, then what we can do is we can again form a right angled triangle, because we're trying to find this total length here, right? So we need to know what that length is here. So if I turn that into a right angled triangle, like this, then what are the lengths of this right angled triangle? Well, we know this hypotenuse because look, that is 9, it's the radius of this bigger circle, and that is 6 because it's the radius of the smaller circle. 9 plus 6 is 15. So we know that this hypotenuse is 15. We also actually know this small length here as well, because look, from here to here, that length is 9. But look, that's 6. This is 6 here, because that's 6. If that's 9 and that's 6, then this length here would be 3. So that length here is 3. And then basically using Pythagoras theorem, we can then find what this length is. But we also know what that length is here, because look, that is 6, it's the radius. And we know that length is 9. So therefore, the total horizontal length of this rectangle is the 9, plus this side of this right angled triangle, plus the 6. And then you just do that total length times by the 18, and that would give you the area of the rectangle.